Get you more.
I'll try.
All right, we're ready for our last presentation today. If you guys remember earlier, Katie and Brooke came up here and talked about the 4-H presentation at TVGS. We had a success story, and they showed a couple photos, the kids and our drone operator out here. He's going to present for us. That was fun.
Oh my God, I'm not yet, not there yet, but
Maldonado, UAS support specialist with more than 20 years of experience in CAD software for surveying, engineering, and land development. So please welcome Omar.
damn, I'm getting old. 20 years. Well, sounds heavy when somebody else told you about it. All right, guys. So my name is Omar Maldonado. If you stay up to here, so you made it. Congratulations. So, all of us. Actually, thank you for everybody for presenting all the other great information that we have. So we're gonna be talking about something that it's a hot topic in these days, drones, but not as a toy. I mean, it's a toy, but it's a tool actually. Well, very expensive toy. It's gonna call it like that. So we're gonna be talking about who we are, what we do, type of drones and data deliverables that we have, and some partners and questions. But again, if you have any other question in the middle of the presentation, let's gonna have this like a conversation. I don't have any problem with that. So Sitech, SISO is a division from Sitech, right? Sitech, our office is in Smyrna, Georgia, but we provide services Alabama, Northwest Florida, and Southwest. So basically what we do, we provide services on SPS system or sites positioning system, machine controls, and all the construction stuff that the guys use in the field. In our case, well, we work with drones. So I got a question for you. Whoever had experience with drones, like flying drones? Not that many. Are you sure about that? You're sure about that? Okay. Again, who had experience with drones before? Let me see. That's why I'm not a drone builder. So, well, that was my first drone. And the only thing that we've done before that or after that, it just basically, now that we can fly a piece of paper, right? Just add a camera on it, right? Now we have a drone. I'm not gonna throw that thing. Okay. So many of us, we've been on this situation. Like back in the days, we used to do our design, survey plans and everything on a piece of paper, right? And then we switched to CAD. When we hear CAD, it was like, something great. And then survey equipment. Now, drones, right? Well, even we have drones, we need to go back sometimes to the basic, okay? So even though, the tools that we have, they are not replacing anything. They're just matching our needs, okay? So in our case, SISO, we basically provide UAS support for multiple types of projects. And we try to provide those services with the results under attend. And I want to emphasize, I want to be specific like on repeatable, right? We want to have that data repeatable. When you go to the field, collect the data with the drone, you want to do this fast, but not because it's fast, you can't skip the details, okay? So I always said, drones are here to stay, but not to replace the surveyors, okay? We always need the survey on the ground to QC our data, no matter what drone you are using, or no matter what software you're using for processing. And that's what we do. So some of our customer here in Florida, Alabama, Georgia Power, some of these guys, you saw probably their logos, actually, Civil Patrol. So they trust our service and sales and support for their needs. So most of them, they're contractors, engineers, surveyors, and recently, a lot of people from environmental departments, they are looking for that type of tools on their projects. So when we talk about drones and SISO air, just realize that actually this number, it's low right now. 415,000 certified pilots. And that's a lot, right? So we're trying to do everything for them. Software integration, training, hardware, and deliverables. Why is this so important? Because we as pilots, we go to the FAA website, get the test, Part 107. Yeah, you're a drone pilot. They don't teach you how to fly. That's gonna be honest. It's weird, right? Well, some people is when they get a drone in their hand, they're shaking. First time that I did that, I was scary, right? Because it's a new technology, right? And we want to be responsible. And then in our industry, GIS, surveying and engineering, we hear about typically these terms every single day. Photogrammetry and LiDAR. And some people are like, what is photogrammetry? What is LiDAR? What is that? Well, it's simple. Photogrammetry, basically, we just collect images or photograph, right? Without overlapping, we use the software to generate 2D and 3D maps. And that's typically what we do. And then when we go with LiDAR, what is the difference between photogrammetry and LiDAR? Well, LiDAR needs light detection and ranging. It's a remote sensing that uses light in the form of pulse laser to measure range. So that's the two different of things that we can get from drone. We can get other stuff like methane detection and other stuff, but for these cases, this is the majority of what we do, right? We see this on the surveyor, construction, GIS, and environmental, and a lot of people, right? So when we hear that, the next question is, which one is better? LiDAR is better. Photogrammetry is better. I have a fixed wing that I can fly 200 acres in 5 minutes. It's better. Well, not exactly. Both are good, but they're different, okay? So in the case for photogrammetry, we can have true live imagery. We can have analysis, obviously it's cheaper, right? And then the problem with photogrammetry, it comes when you have vegetation, different terrains, slower processing, clouds, bugs, all this stuff. Photogrammetry might not gonna work. Well, and then we have LiDAR. Well, you can see through the vegetation, you can work, you can use the LiDAR at night. Environment is fairly complex, you can use LiDAR as well. The processing is a little faster, and it doesn't matter if it's cloud. Well, the problem, you don't get images like the way that you get with photogrammetry. And then, obviously, the workflow and the cost for the LiDAR are higher. Well, at some point, both match. Photogrammetry and LiDAR, you can get powerful analytics tools, you can get absolute accuracy and relative accuracy of both. Okay, so there's no one is better than the other. No, you can use both. It depends on what case you're working on in that case. And when we hear about drones, typically the people see, quadcopter, that's the most common drones, right? And then we have the fixed wing as well. Well, the fixed wing, it's literally like a plane, right? Some of them, they have VTOL, vertical takeoff and landing, and they can use it for more larger area, right? You can fly faster. You can fly specifically like cases that we're going to be talking about shortly, where you cannot use one of these. You have to use one of these. Why? Because you have to save time. You have to save money. You want to have that data faster, right? Well, and then we have the quadcopter, smaller, cheaper. The benefit of the quadcopter is that you can put this kind of drone in location where you can't fly a fixed wing. Okay, the fixed wing, you can fly how many acres, whatever, in half hour, but you cannot fly that around the building at a lower altitude because you're gonna crash. So that's the difference between both. Again, same tool, same tools for different purpose, okay? Now, when we try to apply that data, what can we get? Well, we can use it for survey and mapping. So for project planning, construction progress, elevation maps, vegetation control, insurance, especially after the hurricane, regulatory compliance, that's one of them. But for the mining and construction industry, we can get pit and dump management, stockpile management, and all the other stuff that is related to that. Well, what about inspections? What about infrastructure, cell towers, 3D models for bridge inspection, roof, buildings, railroad, power lines, which power lines even before the hurricane is a problem. Well, all that data comes from the drones, believe it or not. And now some people, some of our customers, sorry about that, it's been talking too much all day long, and it's more than 3 p.m. Another application that we can use for the drone, we talk about that a little bit, is disaster damage assessment management. And actually, forgot the name of the guy this morning from the pastry. They're using drones to calculate and evaluate all this damage from the buildings or the houses or the properties instantly. They take the image from the drone and the AI software that give you, right, all the information that you need. Digital twins. We hear about that like a lot. Now we're listening like digital twins, digital twins, digital twins. What can I do for that? Well, we can do structural damage evaluation and architectural preservation, and even for transportation and survey models, because you're gonna have a twin of data that probably is not gonna be able to get just for a conventional survey. So now for the people that need to redesign bridge, buildings, even the infrastructure, they use that data for that purpose. Obviously, again, it depends on the tools that they're gonna get. Bathymetric survey. Well, some people, in some cases, we have to go with the boat, conventional bathymetric survey, right? Get the boat, get the data. Well, now we can use the drones for that as well. And actually, there's some, I don't want to call it like this, but there's some drones type of boats. It sounds weird, but now they're using that type of technology where basically they have a drone that you can fly and get into the water and get that data. Too much complicated, right? That's too much for us, right? Very expensive as well. But even though we can have that data to evaluate like erosions on the coast or something like that, right? So it's easier, faster, way more cost effective every time that we need to go and then do these type of projects. What we can get at the end, ortho maps. Basically, we can fly the entire site. We can get it to compare the design line work, the surface of the current project versus the existing. We can get to measurement and track progress and make the right decision. Now, why do I say that? When we see this, and when we use the DTM and the 3D models, and actually this is not a picture, this is an actual 3D model, the screenshot of the 3D model. One of the biggest problems that we have here in Florida, especially for the contractors, is that the designers, they spend a lot of time doing all these fancy development or whatever, right? They go to the bid, whatever contractor, get the contract to build that. They go to the site, they clean up the whole thing, ready to start. They have the model, right? To do the cut and fill, do the ponds, do the roads, do everything. And suddenly they have to stop because the original estimators, they were using some survey or even contour maps or contour topo maps from 1978. Well, they were using a 1 foot contour. Well, they skip the swale, crossing through the entire 500 acres. Who's going to pay for that dirt? How much it cost to stop the construction? Again, who's going to pay for that? Well, can we use the drone even before we started, do our flight, do our analysis of the dirt on the earth, vegetation, and everything that we have before we started? And sometimes even we have to stop and then talk again with the engineer saying, hey, there's a little problem here. What problem? Just a 2 foot difference on the dirt on 1,500 acres. What are we going to do? We can see the problems before even we have it now. So this is the data that we can use to avoid those problems and, a lot of headaches ahead. Another thing that we can do, especially with photogrammetry, is that we can have a progress of your site using the line work that we have. So the engineers, they were working for months and months, having all these layers for the road, center line, walls, everything. But sometimes we can't see it, right? Well, if we have a tool, we go there and fly it, the entire project, get the existing condition. Well, I already have my proposed design on the surface and my line work on top. So if there's any change on the design for whatever reason, that never happens, right? Well, we can visualize it, we can see how much money is going to be, how much dirt is going to be affected, or how much money we can save or we can waste if we go with another plan B or plan C for the design at the end of the day. So we can have this data probably in around 2 days. When I saw, every time that I talk about this, it's I don't know, got something in my head. When I started doing CAD, anyone had experience with CAD, Civil 3D, something like that, right? How long it takes to do a profile? Like, I don't know, like 5 years ago. Not Civil 3D, just basic CAD. Hours, sometimes days. Profile, cross-section, by hand. The first time that I saw this, they just click. Here's your design. I almost killed myself. Why? Because I know the pain, and you know the pain that it's create a cross-section, an alignment. And when you're done, your computer freeze and you lost the CAD file. Start over again. Well, now with the software that we have for photogrammetry, we can use those tools even on your phone. So now we don't have to actually have Civil 3D or Active or any other software installed. We can do this and verify everything same day after we have applied. Oh, so wait, something's going on with my design. This part was supposed to be here. This part is supposed to be 2 foot lower. What's going on? We can see the problems faster. We don't want to have problems, obviously. But if we are in this industry, this is what we're gonna get. And then again, we can do measurement of stockpiles and go on field map surface area. And we can see everything from the top, okay? And this is one of the cases. This is one of my, this is our customer. I used to work with them, and this is something that was published. We had an interview with them. They started this project in 2022. And in January 2024, they were able to move 2 million cubic yards. Can we try to do this by hand? Just conventional survey? Do you know how many points do we need to get through the entire site, basically every week? Well, they were flying it and processing the data next day. So that's how the tools that we use, it's designed for that. So let's gonna talk about we talk about a little bit of photogrammetry. It's gonna talk about LiDAR. I'm not gonna do like a class of LiDAR here, okay? Just in case. So this is just a basic flight. Now you see it, you see the ground. How many points can you count over here? I'm gonna tell you. And now the vegetation is gone. That doesn't mean when I talk about LiDAR, some people is like, oh, so I can see through the walls. No, it's not Superman. Okay. So what the best way to explain this is like if you're in a like high high dense vegetation, if you're in the middle and then you look up and then you see a little piece of the sky, the LiDAR is gonna make it. So the LiDAR is gonna see the bottom of that side, of that location. Well, having a tool that allows you to filter all that information, low vegetation, high vegetation, medium vegetation, power lines, buildings, structures, in a 15 minutes flight, well, that's something, right? So these are the deliverables that we can get with the LiDAR. We can get a point cloud, we can filter out the entire point cloud and just have this, just the ground, right? Millions of points, sometimes we don't need those millions of points. We can decimate that information as well to make it easier to handle on those CAD files on our computer. Now, digital twins, when it comes for infrastructure, it's more than 3 p.m. My brain started to, crash a little bit. So cell towers, every time that there's a storm or a hurricane, we don't care about anything. We just care about losing our internet connection in our phone because we cannot do the, how you call it on the Facebook, I'm safe, whatever. Right? Well, of course, we are worried about this type of structures. They need to be healthy. They need to be safe. They need to be evaluated every, I don't know, every 6 months, every year or whatever. So they want to know how good in shape those cell towers are based on the location, right? Another aspect of the 3D model / digital twin is that we can see even other stuff that we don't want to see. Like this is the abandoned stadium in Miami. We were flying it. And as you can see everything. And sorry about some profanity words on this one, but this is what it's done for the drone. So anyone can inspect and do measurement based on that stadium. That it's abandoned. It's too bad that it's abandoned. It's really cool, but this is the type of data we can get. And actually, that flight was hard, like around 12 minutes to generate a 3D model, an actual real life 3D model. Pretty cool, huh? It's too bad that that stadium is abandoned. Okay. Okay. Now, what type of drones we can use for that type of projects? Like this one, this is the most famous orange drone on the market. Have you ever seen this one? Right? No? Yes, no, yeah. It's like 50-50, right? Well, that drone, you can use different payloads. Basically, to fly for photogrammetry, swap the payload, put a LiDAR on it, and refly. Pretty quick. How good is that drone? Well, yes, it is like that. 731 acres, 40 meters, one set of batteries for granted. And I know that because I did that one. Even myself, I was like, I can't believe it. I was like, no, that was like an error. And I recalculated, and yes, it was just like that. So different tools for different projects. Now, we might not gonna be able to do this with this one. Well, but we can carry some payload that you cannot carry on the fixed wing, right? you can carry up to 6.6 pound of payload capacity for that little drone, the Inspire Flight. Quadcopter, same thing. You can swap the payload. It might gonna be a little slower, but you can get into location where it's gonna be very, very difficult for a fixed wing. And another drones that we can use is the Harris. Obviously, you can carry. Don't remember if it's like up to 15 pounds or even more payload. I don't remember. I don't have the number. And they are hybrid. There's one model that is hybrid. You can be flying for a couple of hours. Very nice, very interesting. And the big brother of the Inspire flight, the AF-1200A, which that's the previous version. And the little one, the Skydio. And something pretty cool about that drone, it's not only for GIS construction. The police department, they use it for search and rescue because has thermal capabilities. You can do a 3D model of the building at the same time collecting data for thermal at the same time. So you don't have to refly it twice. So that little thing, it looks really small. And then that's one of the most scariest behavior on the drones because you have to pray for it. Because when you set up your flight plan, you just click play and the drone will do what it needs to do. So you have zero control of it. Kind of scary, but it won't crash, except if you shoot it, obviously. You don't want to do that. I know you're not going to do that. So other payloads that we work, finished LiDAR system, we work with a lot of payloads. I'm not going to go through that, all of them. But these are some of the partnerships that we have for hardware, Wintra, Whisper, Skydio, Inspire Flight. And then we do training on this software as well. Propeller, Pix4D, LiDAR Mill, GeneX, and so. Those are like a lot, right? Any question? I'm running out of time for a Friday.
Success using something like NDVI or LiDAR to distinguish between differences in like plant communities, like species level.
Yes. So the Wintra has a payload that I didn't mention it, but yes, there's a multi-spectral camera on it. I am not an agricultural guy, as you can see, obviously. But yes, you can fly. In that case, obviously, that payload has, if I am not mistaken, 6 lenses for NDVI. You can fly lower, and some people, we have some customers using those cases for even for bird nest. Did I say it right? Bird nest, yeah. So if they have like wetlands or there's some kind of nest, or they can fly with that drone. Obviously, we detect different colors. They can locate what they call anomalies, but they're not anomalies. They're like those nests for those birds. And some cases they are using LiDAR at the same time. But having just one drone that you can swap the payload and refly it is going to save you a lot of time. So basically, you can do 200 acres. You can fly LiDAR photogrammetry and multispectral, and you can be back at home before lunch if you want it. So, yep. Any other question?
How deep can the LiDAR go in the water and get accurate depths, elevations?
Well, when you say LiDAR on the water, you're thinking about like flying around water?
More like a shoreline. Say a canal 20 feet wide.
Well, there's some LiDARs that you can fly and you can go through the water. Those are like 6 figures, kind of. I'm not experienced with that, but yes, a Phoenix LiDAR system has one of those. What we think like very, very, very interesting, it's doing bathymetric survey with drones. So basically we use a sonar on the drone, and we set up the same flight plan, like the one that we're gonna do on a site, right? Create our boundaries, and then the drone is gonna do a consistent flight, right? And that sensor is like around a couple of feet under the water, and it's gonna send those poles around the area. Or the drone can just basically fly put that sensor on the water, fly back, and do this again, like a little frog, just jumping all around. Kind of scary because you're flying probably, I don't know, like a $50,000 drone, like 2 feet off the water. You need to be a good pilot for that, and a good insurance. You should have a good insurance for that. But yes, it's possible. Depends on the sensor that you can get. Yes, it's possible. We had a customer recently that's what they're using. No, I'm not gonna give this one for free. That's it. Thank you guys. Thank you for your time. I know that it's a Friday, so have a good weekend.